Alrighty, so our second rule in non-right angled triangles is called the cosine rule. So we use this one where we are dealing with three sides and one angle. So again, I'll refer you up to this triangle up here, our nice little non-right angled triangle. And again, we notice that our sides and our angles are in proportion. Big side, C, little c, is opposite big angle, big C. Small side A is opposite small angle A. This time, however, we're going to be dealing with three sides and one angle. Now again, there are still three sides and three angles in this triangle, but we are given information either about three sides, so we might be given A, B and C and asked to find any one of these three angles, or we're given two sides and an angle and asked to find the third side. So the cosine rule looks like this. It's got a little bit of similarity to Pythagoras' theorem. So we end up with a squared equals b squared plus c squared. Those are all sides. That's just your Pythagoras' theorem, minus 2 bc cosine of a. A couple of things to draw your attention to straight away. We notice that A, B and C, and then this B and C here are all sides. The only place we see an angle is here at the end with our ratio cosine, of course because it's the cosine rule. The other thing, if I am finding, this is for if we're finding a side, similar to the sine rule, the rule is actually the same if we're finding an angle, we just represent it differently. We manipulate that and we end up with a slight variation of the formula, of the same formula. So this is if we're finding a side. What you'll notice is if I'm finding side A, so let's say I wanted to find this side here, I must know what angle A is. I can't use angle C and try to find side A. I need to, whatever I am finding here, I need to know the angle here. And maybe we have to do a little bit of geometry and some angle sums of triangles to find that, but those two must be matching, if you'd like. The second way that we can represent this, if I'm finding a side, is that cosine of A equals b squared plus c squared minus a squared over 2bc. Now again, you should notice some similarities there between our first version of the formula and the second. All I have done to get from this version down to this one, which is what we use to find an angle, to start with, I have manipulated my formula to say I've added 2bc cos A to the left hand side, and I have subtracted a squared, and then I've divided by 2bc. I might in class show you a little bit more of that manipulation, but for now they are the same formula, just manipulations to provide two different versions. Obviously, if we're finding an angle, we want cosine A as the subject. We want cosine A over here on the left by itself. And if I'm finding a side, I want a squared by itself. And we've got a couple of little tips and tricks of how we look to finish an answer for these, because they can offer a couple of little places to make simple errors if we're not careful. Let's look at an example. Alrighty, so we can find any one of these angles here. I'm going to find angle A. We could find any one of those angles because we know all three sides. Okay, but in this case we're going to find angle A. So to start with, I'm finding an angle. So I'm going to have cosine A. Now, getting my sides right is important. The important pair to match up is the angle and the side that is opposite that angle. So in this case, A will be 9. It does not matter whether B is 7 and C is 10. Those two can be interchanged because all I'm going to do with them is I'm going to square them. Cosine A equals b squared plus c squared minus a squared over 2 times 7 times 10 bc. Now again, if I switch the order of these two, no change, because all I do is square them, they're both positive, and then I multiply them in the denominator. So getting those two in the right order really isn't important. Getting this one right is extremely important, because if I go and subtract 9 squared or add 9 squared, that's very different. Okay, so straight away what I would direct you to do is put all that into your calculator. And I hope what you've got is 0.4857, something like that. Now again, similar to our sine rule example, that's not our answer. Okay, it's a correct process so far, but clearly our angle is not 0.485 degrees. We need to go and use that inverse cosine. Okay, so A equals our inverse cosine using that shift button in our calculator of the answer. Please don't round it. I'll make note of that. Don't round yet. We'll round at the end once we actually have the angle. If we put in the inverse cosine of 0.48 or 49, we're going to get a slightly different answer as if we use the exact value. So if we go and do that, what we end up with is A equals 60.94 and so on. And I'm going to call that 60 degrees and 56 minutes to the nearest minute. Okay, again, we don't want to round to the end. If we're finding an angle using the sine rule or the cosine rule, we're going to end up using that inverse cosine or inverse sine depending on your rule. And most important thing for this rule is matching things up correctly. Making sure that if we find whichever angle we are finding, we've identified the side that is opposite that angle. Alrighty, for this one we are going to find side C. Okay, it's the only side we don't know. Again, we've got our 47 degrees, so I know that C is opposite 47 degrees. So similar to our process last time, we're going to use our side version of this formula. As I mentioned before, it's the same formula, just manipulated to suit our purposes. So we end up with C squared equals A squared, 7, plus B squared, 9. Once again, it doesn't matter what order those two go in, because we're going to square them and then we're going to multiply them. So I have cosine 47. Okay, let's put all that in our calculator. And we end up with 44.068. Here's that little trap I was talking about. Our side length is not 44. If we look at it, it's out of proportion for my triangle. Even if this angle were extremely large, 150 degrees, we would still probably not expect that side to be that much different from our 7 and our 9. What we notice, and you may have already, we need to square root it because we've got C squared. So C equals the square root of 44.068 using the answer button on your calculator, not a rounded version. And we end up with 6.638, and I'll call that 6.64 centimetres to 2 decimal places. We can read that that's a 6. So again, for the cosine rule, equally, but possibly even arguably more than the sine rule, getting our sides and angles matched up correctly is very important. So I hope that makes sense. Again, could we make some notes on this, noting those two versions of the formula? And I hope we're okay with this.